Today we're going to look at calculating the molar heat of solutions. In our first worked example, here we have 11.2 grams of sodium hydroxide, and that's at a temperature of 19.2 degrees, and that's dissolved in 200 mils of water, also at the same temperature, 19.2. And when they were mixed, the temperature rose to 31.4 degrees Celsius. Now we have to calculate the molar heat of the solution of the sodium hydroxide. Now in this case, the specific heat capacity has already been given to us at 4.2. Now remember that in the HSC you don't need to remember what the specific heat capacity of water is. It's given to you on your cheat sheet. But in this case, it's been given to us and it reads as 4.2. So how do we start? The first thing we need to do is use our equation. And the equation that we're going to use is the Q equals MCAT. So the first thing we need in this equation is our mass. Now remember, we have 200 mils of water, and 200 mils when we speak about water is equivalent to 200 grams, but we have added 11.2 grams of sodium hydroxide. So we need to calculate what our total mass is, and that's the 200 plus the 11.2. So when we work this equation, we're actually going to have a mass of 211.2 grams. We times that by our constant, which is the 4.2, and then we need to do our change in temperature. So our final temperature is the 31.4, and we're going to subtract that from the 19.2, which was our starting temperature. So we're going to calculate the heat released. Just put that into your calculator as 1.08 times 10 to the 4, and that's going to be in joules. So now that we've calculated the heat released, we need to go back and have a look at the question. And the question's asking us to calculate molar heat of solution. So it means that we've only added 11.2 grams. So we need to find out how much 1 mole is. So what's 1 mole of sodium hydroxide? We need to find out what our molar mass is. I'm not going to go into molar mass because I'm assuming by now you know how to calculate that. So I'm just going to quickly write it up over here. So we have our sodium hydroxide, and that's going to have a total molar mass of 40.0 grams per mole. So now we need to know the heat released by 1 mole. When we do our 1 mole equation, we're going to use the molar heat. So remember, this is this equation. So it's essentially the same, except it's the minus MCAT. Now we've actually already calculated what this is. That's over here. So essentially all we need to do is bung a negative in front of it, but figure out what the molar equivalent would be. So to work that out, we put our molar mass, 0.0, and we divide that by the mass that we actually used, which was the 11.2. And then we're just going to add in the heat that we've already calculated. So that's going to be 1.08 times 10 to the 4. Now put that into your calculator, and that's going to give you 3.86 times 10 to the 4. And if we move our decimal point around, that's going to give us 39. And I'm going to round up there. They've given us our heat capacity in two significant figures, so I'll give them the answer in 2 significant figures. Again, if you want to keep it to 3 or more, that's fine. So it's going to give us 39, and remember I've moved the decimal point, so it's now a kilojoules per mole. Now don't forget about this negative symbol. So we've calculated the MCAT already. We've now calculated the molar capacity of it. Put a negative in front of it, and that's going to give you the molar heat capacity of 1 mole of the sodium hydroxide. Now part B of this question wants us to use this heat of solution to calculate the expected temperature rise when 23.6 grams of sodium hydroxide is now dissolved into 1 litre. So we're going to write down what the heat of solution was. So remembering that it was, let me leave that, let me change my pen, that the heat of solution was calculated to 39 times 10 to the 4. Now remember, I'm not going to bring the negative across. The negative was to show us whether it was endothermic or exothermic. So this is the actual heat released. So I'm going to use this in my equation. So the first thing it wants us to do, we need to find out how many moles of the NaOH is actually used. So in this case, I'm using 23.6 grams. I know from my previous question that the molar mass of the sodium hydroxide is 40. So remember, this is for 1 mole. So I want to find out how many moles is actually used in the 23.6 for this equation. So I'm going to divide them, and that's going to give me an answer of 0.590 moles. So this is the heat released when, this is the number of moles used, and I want to find out how many, what's the heat released by this amount of moles. So I already know what the heat capacity is because, again, we just calculated that. So I want to put in the amount of moles that we are using, which is the 0.59, and I want to times that by our heat capacity, 3.9 times 10 to the 4. Actually, notice I should actually put that point in there, make that clear. And that's in joules. Better write that up there too. Okay, so that's in joules. And when we put that in our calculator, we're going to see that we're using 2 times 10 to the 4 joules. Okay, so we want to see how much are we actually heating up here. Now, we have 1 litre of solution, but remember we have added 23.6 grams. So we actually have a total, I'm going to change colour here, I'll go to blue. We're actually going to have a total mass of 1023.6 grams. So we need to calculate temperature rise now. So that's essentially what we need to calculate. Now, we use the same equation as in the Q equals MCAT. However, we know what the Q is, and we know what our mass is, we know what our water constant is. What we don't know is the change in temperature. So we need to change our equation around, and that's going to bring it to, here's our temperature, and we're going to put, moving it around, we put our Q and then the M times the C here. Okay, can you see what I've done here? This is our unknown. So I've moved these two across, and when you're moving them across, they divide. So now that we have all our answers, it's as simple as plugging it all in. Now this is our Q. So we will put 2.30 times 10 to the 4, and we're going to divide that by our mass, and here's our mass, 1023.6, and then we're going to times that by our water constant. Remember from our previous question it was 4.2, and that's, put that in your calculator, and that's going to give us 5.3. Now essentially this is degrees Celsius. So it's basically telling us that when we add 23.6 grams of sodium hydroxide to 1 litre of solution, it is going to raise the temperature by 5.3 degrees Celsius. So what do you do now? Watch the video a couple of times. We need to get really familiar with how to use these equations. So work through it with me, do it a couple of times on your own, pause the video and see how you go. And then on the mile, I've put up some practice questions that we're going to cover in class next lesson. So have a look over of those and see how you go.